Today we're going to discuss weight versus mass. A lot of times throughout the year we've got these two concepts very confused. And the reason for that is they're slightly related because in order to calculate weight, you need to know the mass of whatever the object is you're weighing. Alright? They are related, but they are absolutely not the same property. I mean, for instance, just look at what the units we use to measure them are. We measure weight in units called newtons. Alright? And the symbol for Newton is the N. Pay homage to Sir Isaac Newton. And the units we're going to use today for mass are kilograms, the base unit being grams. Okay? I'll put this kilograms over here. Kind of flip-flop them there, but it's okay. Okay? Alright, so mass, as you may recall from the beginning of the year, is the amount of matter in an object. That means like how many molecules. Alright? It's the total number of molecules in an object. Okay? Now, weight is the force of gravity acting on those molecules. Okay? And we can use the calculation of Newton's second law where force equals mass times acceleration, and depending on where you are, whether you're on the Earth or Mars or the Moon, the acceleration will change. But wherever you are, it will remain constant for the most part, or pretty close to constant. So here on Earth, acceleration due to gravity is 9.8 meters per second squared. So you can use force equals mass times acceleration, or weight, W, equals mass times gravity, M times G. Alright, so that will remind you that wherever you are, you have to calculate for acceleration the gravitational pull of the planet or spot where you are in the galaxy. Okay? So for instance, using those formulas, okay, we would have, let's say we have a we talked about a 50 kilogram object in the last one, and we said the moon's gravity was 1.65, but we're going to use 1.64. That's about 1/6 of the Earth's gravitational pull. So if we said that we have the mass of an object, and we said that object's mass is 50 kilograms. Okay? Remember, force equals mass times acceleration, or weight equals mass times gravity, right? Now, if we had acceleration due to gravity, on Earth we would have 9.8 meters per second squared. That same mass put on the moon would accelerate towards the moon's surface at 1.64 meters per second squared. So if we run the calculations, the force, or the weight, all right, the weight of this object on Earth is 490 newtons. Okay? That's on Earth. And then that same object on the moon has a weight of 50 times 1.64, which is 82 newtons. So you can see the weight of the same object on the moon is much less. And it's not because it lost any mass, which means the number of molecules it's made up of. Okay? It's because the acceleration on the moon due to gravity is about 1/6 of what it is on Earth. Okay? Now, some things to remember about weight and mass. First things first. Mass does not change. Your mass, just like in that example, was 50 kilograms on Earth, and it was 50 kilograms, it was 50 kilograms on the moon. Okay? Weight, on the other hand, is very much dependent upon where you are in the galaxy and how much force of gravity is being applied to the object. All right, so weight is dependent upon the force of gravity acting on it. So we said on the moon, the force of gravity pulled it towards the moon's surface at a rate of 1.64 meters per second squared, and on Earth it pulled that 50 kilogram object towards the surface of the Earth at 9.8 meters per second squared. Okay? So that was our example before. Example, on the moon, your weight would be about 1/6 of what it is on Earth, and that should be a capital E. All right? Because the force of gravity is less. Okay? You're still made up of the same amount of molecules that you were before you went to the moon. You didn't disappear. No part of you disappeared. So you took your mass and you traveled up to the moon. Get your mass on the moon is basically what's going to happen. When you get your mass on the moon, you're going to find that you are 1/6 of the weight you were on Earth, but you're all still the same amount of mass you were on here on Earth, okay? That's basically it. You just have to remember that weight is a formula, all right? And the formula for weight, okay? Weight is mass times gravity. Okay? And remember, weight is still measured in newtons. It's the same, very similar. We have kilograms and whatever the gravitational acceleration is. All right? So write gravitational acceleration. Okay? So depending on where you are, that may change. This number may change. Okay? It's very similar, like we said. Force equals mass times acceleration. And it's the same formula, but we're talking about the acceleration due to gravity. Okay? That's it for today. If you have any questions, please ask us. We'll be happy to help you. Have a good night.